In this presentation, I will present an opportunity for increased usability and readability in particular for query writing education. All right. Different relational database management systems, or DBMSs, output error messages for queries with syntax errors. And this is intuitive, and the concept is similar to programming language compilers. On the other hand, and contrary to many programming language compilers, many DBMSs identify semantic errors but do not directly inform the user that there is an error. Take the query shown, for example. Perhaps the user meant to retrieve all information on orders where the order total was 0 or 100 euros. And since this query contains no syntax errors, it is executed and an empty result table is returned by the DBMS. The user, and novice user in particular, may think that since they got results instead of an error message, there is nothing wrong with the query. From a DBMS perspective, however, different things happen, even though the user is not aware. If we look at PostgreSQL's query execution plan, it reads one-time filter false and never executed. This means that no matter what data there is or there are in the database, PostgreSQL sees that the query is semantically incorrect and never evaluates the expressions against the database data. Oracle database does the similar thing revealed by the query execution plan, which reads null is not null, indicating that Oracle doesn't evaluate the expressions in the query either. So, as I have demonstrated with one example here, and there are a total of 6 different and common semantic errors demonstrated in the conference paper proper, many database management systems identify many semantic errors but do not directly inform the user who writes the query. And this is problematic since novice query writers need more support than professionals, and also professionals would arguably benefit from increased support in, for example, debugging and optimizing queries. It is problematic that the problems the DBMS identifies in the queries are hidden in the query execution plans, as these plans are typically in use in database optimization tasks rather than querying. And these query plans can be difficult to read, especially Oracle's null is not null may be incomprehensible for a novice. But as DBMSs identify these problems in the first place, this presents a significant opportunity in utilizing what the DBMS already knows. What we need to do is catch these pieces of information, iterate them in a more readable form, and present them to the query writer without the need to separately consult a query execution plan. We have already started working on a tool which utilizes PostgreSQL query execution plans and provides hints to the end user in a more readable form. We also invite others interested in participating in the development, as the tool is open source and freely available to anyone. I personally believe that this is a great opportunity to bring DBMSs forward in terms of usability and thus facilitate the teaching and learning of query languages. Thank you.